Hello, I'm Chris Cohn, a technical marketing engineer from Mentor, a Siemens business. This video shows how the Expedition Substrate Integrator quickly assembles an advanced IC prototype that can be checked with the Calibre 3D stack. Start your design in xSI by creating a new project. Define a new floor plan, in this case FOWLP for fan-out wafer level process, which requires an Expedition library. This generates the floor plan layout window to assemble the prototype for the substrate. Now a CMOS die can be added. We'll call this chip 1 with a refdes of U1. xSI supports all major IC formats including leftdef and Verilog. This CMOS die uses a CSV or spreadsheet format file. Columns can be remapped to the required design attribute, but we don't need to do that here. We'll need to ignore the header of this file and specify the pad size to be 30 microns. Let's specify this to be a flip chip with a live bug definition perspective. This die is used twice in this design, so we can create a new instance calling it chip2 U2. Then we can open the device properties of the master and define the connectivity for chip 1 and chip 2. Connectivity can be defined in xSI using a Verilog netlist, but in this example, we'll use a CSV file. As before, no column mapping is required. We can now see the die-to-die connectivity and pin coloring defined in the previous steps by making the FOWLP floor plan layout active. Let's close the connectivity and pins windows to maximize the size of the graphical floor plan window. We can do a quick rotate and move the instances with specific locations to be added later. Now let's add the C4 interface from the FOWLP to the package substrate. We can use an AIF file definition, perform an analysis check, which gives us the size. The part type is set to BGA, and we'll use a live bug definition perspective. The netlist was included in the AIF file, so we can see the connectivity to the two die. This design needs power and ground decoupling, and we can add a capacitor from the central library. We'll specify the part in the central library input and set it as a general part type with a live bug definition. After 3 additional instances of the capacitor have been created, we can specify the specific locations and orientations of each of the parts in the local components form. This design is ready to start a Calibre 3D stack run. We'll cover that in a different video. Thanks for watching, and be sure to look for more video content on Mentor's advanced packaging tools.